Today is not my day. All right, let's do this thing. First off, talk about inverses again, so we're just more of the same. We'll go over a couple different things. But first things first, is this thing a function? A couple people say no, a couple people say yes. How can we tell? Vertical line test, right? So I take my awesomely straight drawing skills. Calm down. I draw it over and over and over again, and I only hit the graph at one point. So is it a function? Absolutely. Thanks, I've been working on it. Okay, secondly, how do we know? How do we say how we know?
Vertical line.
Yeah, we said vertical line test. X's don't repeat. So vertical line. Oh my gosh. Yeah. I know what it looks like. Here we go. Vertical line test. Clear as day, right? Right there. All right, our horizontal line test is very similar to the vertical line test, except what? Yeah, it goes horizontal, and it's going to be a test to determine if a function is one-to-one. One-to-one. What one-to-one means is if there is one x paired up with one y, and that's it. So like the linear parent function is one-to-one because every x has one y. The cubic, any of those parent functions have one x and one y, other than the quadratic one, absolute value. They have multiple y's, they have multiple x's with the same y. So how we tell if something is one-to-one is we're just going to draw a horizontal line. But remember, just like the vertical line test, it's anywhere. So if I erase all these lines here, my awesome straight line. If I were to draw my horizontal line right there, does it pass the horizontal line test? Does it hit my y values only at one point? No, it's got like the same y values a couple times, right? Right there, right there, right there. So this number one would not be one-to-one. That's all that means. And it's not a bad thing. It's not a good thing. It's just a fact that graph is not one-to-one. And that's how we actually also tell if the inverse of a function is also, if the inverse of something is going to be a function, is by the vertical line test. And so for part 2, for A, B, and C, all we have to do is the horizontal line test and to tell if something's inverse is going to be a function or not. So I do my little horizontal line test there. If it hits it at more than one point, then the inverse is not going to be a function. So for A, not a function. You can say no, you can say inverse, not a function, anything like that. We're not talking about the actual graph. If we're talking about the actual graph and I want to determine if it's a function or not, I would go ahead and draw one of my awesomely straight lines, and it only hits at one point. But we're not talking about that, we're talking about the inverse. Alright? What about B and C? Yeah, I can draw one line there, I can draw another line here, there, whatever. Any of that business, I can do it. So yes, it is. And once again, yes, it is. Okay, number 3. How do we find an inverse algebraically? How did we do it yesterday? We could sum it up in like 5 words. Switch x and y. Cool, I like it. Good start. Switch x and y. And solve for y. Well done. Switch x, y, then solve for y. Carter gave you the definition for one-to-one function, one x value. Paired with one y value. One x value paired with one y value. Questions? Does that make sense for the most part? Hopefully. All right. 4 through the back, we're just solving for the inverse. So number 4 is kind of like a softball. Starting kind of easy. What's the first step? Yeah, switch x and y. If you want to go ahead and write, y equals first, negative 4x plus 5. My next step then would be to switch x and y. I'm reviewing last night's homework. Solving for y now, so we're moving something, aren't we? Moving 5, yeah. Sorry, I need to recall that. So x minus 5 equals negative 4y. Comes up to that. Yeah, divide by
Negative 4.
Negative 4, right? So y equals not negative 4. How do we write it? How do y'all write it? X minus 5 over negative 4. Other way to write it, you could have done negative 1/4, and then x minus 5. By the way, cool. Be sure you do the function notation now. Pause a second. Now we got it. Okay, what's our first step?
Switch x and y. Well,
Switch x and y. Alright, so first we got y equals square root of 3x.
Then you
Then
go
we
x
go
equals
x equals.
square root of 3y.
I like it. What now?
Alright.
Yeah, we got to square. We're going to square both sides. So I get x squared equals 3y. And then we're going to divide both sides by 3. So my answer is going to be y equals, I'm going to go ahead and use the fraction out front instead of doing x squared over 3. So y equals 1/3 x squared. Going to use the function notation, that's cool. Yeah. Boom. To the Batmobile. Thank you. Alright, number 6 kind of works the same way. The only thing that's kind of different is saying x is greater than or equal to 0. The reason why they're saying that is because for the inverse, we're only going to use x's that are greater than 0. We'll see here in a second, it's going to be a square root function, and you can't take the square root of negative numbers. So that's why they're saying for a positive x value or equal to 0. So first thing is going to be y equals x squared over 3. Next thing I'm going to do is switch x and y, like always. Always switch x and y. So I get x equals y squared over 3. Now what do? Multiply by 3, good. Now I gotta get rid of that -3, don't I? One thing. Here we go. Multiply by 3. So I get 3x equals y squared. And last thing, if I'm going to solve for y, take the square root of both sides. So I get y equals, and then when we take the square root, something new, I'm going to write plus or minus the square root of 3x. The reason why we're doing pluses and minuses is because when you take the square root of a positive number, so like square root of 25, you actually do have two answers. It's not just 5. It could be -5 or +5. So in the same way here, I could have positive square root of 3x or negative square root of 3x.
Will questions like these be on the quiz tomorrow?
No, the questions on the quiz will be a little simpler. Or more simple, whatever the proper grammatical version of simple is. Yes. Yes. Good question. Question was, do we have to put plus or minus on every square root? Yes. That is 100% correct. All right, as a group, y'all are going to do 7, 8, and 9. You got about 6 minutes.
7, 8, 9. I'm sorry.
He did have
All right, so number 7, first thing, we got y equals 5 plus square root of x plus 2. The first step after we do that is switch x and y. What about now? -5, is that a good idea? Subtract 5 from both sides, get y plus 2. Now what? We just square both sides. So I got x minus 5 squared equals y plus 2. Yeah, let's subtract 2. So I got y equals x minus 5 squared minus 2. And be sure you do the inverse notation.
Is that a positive one or a negative one? F.
That's a -1. One thing I would say is that if you're going to go ahead and square this, you have to use FOIL or box or Xbox or whatever y'all are used to when you multiply binomials together. So if you're going to multiply it out, which I'm telling you, you don't have to right now, you have to do a method like this. And so when you do like the x squared, then -5x, -5x, and then positive 25. And so when you do all that stuff, you could rewrite it. So we're talking about right here. So that would be x squared minus 10x plus 25. You don't have to do that, but if you want to, be sure you do it correctly. Doing it correctly is either the box or FOIL or whatever your other one teacher showed you. Questions on 7? Okay. So let's go to Ocho. This one easy? No? For a couple of this it was? Alright, so the first thing after we switch x and y is that you really need to divide before you do anything else. So if you didn't divide, you might want to erase. So we first divide by 3, divide by 3. So I have x over 3 equals y plus 2 squared. And then my next step after that is to square root. So I have plus or minus the square root of x over 3 equals y plus 2. My last step,
minus 2.
subtract 2. So So I have plus or minus the square root of x over 3, and then I have minus 2 not underneath the square root, which is my inverse notation. If you want to write it the other way, you know, f to the negative 1 of x equals plus or minus blah, you can do that too. Either way is correct. One third x and x over 3 is the same thing. If you put that, kudos to you. So another possible answer could have 1/3 x there, and then minus 2 outside. Okay, the last one I had y'all do was number 9. Or do y'all need more time to write that down? Alright, number 9. Kind of complex looking. Hopefully you had enough room. This one's kind of long. First thing, we got them switched. And then what should I do after that? Yeah, multiply by 3. So I'm going to get 3x equals 5 plus square root of 10 minus 2y. If you can get all the way through this problem, you're probably pretty solid on inverses. Next thing, move 5 over. Yeah, I heard someone say it. Next thing, square it. The reason why we're squaring is so the square root can go away. 2 more steps. Subtract 10 from both sides, so I have this thing still in parentheses. I wouldn't multiply that out. I would just leave it alone. It's going to get messy. We got equals negative 2y. The last thing, divide by negative 2. So I got 3x minus 5, all under the square root, minus 10 over negative 2 equals 1. Like I said, long problem. If you want to rewrite it with the inverse notation, that's cool. A couple other possible answers you could have had is that you could have the negative kind of out here, and then this would be a plus 10 all over 2. If you want that. Either way is correct. Here, the negative 10 divided by negative 2 is positive 10. Negative divided by negative. You could actually divide this out, so another answer could be negative 3x, right? Parentheses, negative 3x, or rather, negative parentheses, 3x minus 5 squared plus 5 over, and this part's over 2. Any of that would work. Whew. Word problem? Alright, we got Judith manufacturing north portion. We got an equation right there. Height is h is the height of the can. L is the lateral surface area. Explain the meaning of the inverse function. So here, what we're saying is that the height, the surface area depends on the height. If I were to reverse it, what would that mean? Yeah, height depends on surface area. Height depends on surface area. Yeah, surface area. That's it. To find it, we switch x and y and solve for y. C, we would plug it in and go. For the sake of time, I will not do that now. I want to be sure I get you the homework, which you have a lovely word problem